Today we're going to keep talking about functions, and today we're specifically going to be thinking a lot about how we evaluate functions. I want to come back to this idea of if I see a function like 4x squared plus 3. Now remember, we said on our last day of notes that f of x, we have to think that that is a y, okay? But we're not going to use y much more, okay? You'll see it occasionally, but for the most part, you're going to see f of x. And we said the other day, we talked about the function machine, and we said, what is the machine doing to x? So in this case, what is the machine doing to x? What is the function machine doing to every x? It's squaring it. Let's kind of identify this over here. It's squaring it. What else? Times by 4. Or multiply by 4 if you don't like that x. Multiply by 4, and then what? Add 3. Okay, 1, 2, 3 things. Okay, every x value that goes into the function machine gets squared, gets multiplied by 4, and then it gets 3 added on to it. Okay? So when I put in a particular value into the function machine, and you remember we drew our little function machine the other day, right? So let's say that I put in a 2. Okay? Well, with our notation here, we would write f of 2. And so now let's see what value the machine spits out. Well, we said we're going to square the 2, we're going to multiply it by 4, and we're going to add 3. Okay, so you just replace the x with the 2. So 2 squared is 4, 4 times 4 is 16, 16 plus 3 is 19. Now, it is very important that we understand this is a relationship. Remember we said it's a one-to-one correspondence. What happened? We put in a 2 and we got out a 19. And that also corresponds to points on the graph. I could say that when x is 2, the y value is 19. Right? And I could do that for an infinite number of points. I could plug in 0. What would f of 0 be? Well, that's easier. 4 times 0 squared plus 3. Isn't it going to be 3? Right? This is 0. I'm sorry, this is 3. Okay, I have an infinite number of points I could put into this function machine, and it will always spit out a y value. All right? This thing winds up being a parabola if we were to put in all of those gazillion points. Okay? So what I want you to get is, I want to actually write down something here. We can conclude from this statement that the value of the function at 2 is 19. Or we could say the value of the function when x equals 2. That's another way we could say it. The value of the function at 2, or the value of the function when x equals 2, is 19. Okay? So, and then we said, of course, that there are an infinite number of points that I could do that with. I could do that with a gazillion and 1 points. All right? So tonight, one of the things you're going to be doing is pretty straightforward. You're going to be asked to evaluate the function. Okay? They're going to give you a function like g of x, and by the way, don't get freaked out about different letters. I could put g of x, I could put r of x, I could put q of x. They all work the same way. G of x equals negative x squared plus 4x plus 1. And then they're going to give you some values like find g of 2, find g of t, find g of x plus 2. And I'm going to go through all three of these because all three of those bring up a different situation. So let's look at part A. Part A is easy. Okay? G of 2 means that I put 2 into the function machine. So where there's an x, I'm going to put a 2. So I'm going to have the negative of 2 squared plus 4 times 2 plus 1. You just put the 2 in and do what the function machine says to do to it. Now be careful with that negative. That doesn't mean negative 2, the quantity squared. It means, technically, it means negative 1 times the 2 squared. A lot of people mess that up. Okay? So 2 squared is 4. So negative 1 times 4 is negative 4 plus 8 plus 1. So that's going to be 4 plus 1, it's 9. Okay, that's easy. G of 2 is 9. There's our first answer. I'm sorry. Oh, not enough coffee this morning. 4 plus 8 is 5. Thank you. Got in a hurry. Sorry about that. Let's look at part B. G of t. This is not a trick question. It just means plug in a t. Well, isn't it going to look exactly the same, only it will have a t instead of an x? Part B is easy. This is going to be negative t squared plus 4t plus 1. That problem's done. All they're asking you to do is plug in a different letter. Okay? You don't get a number answer. That's okay. Now, part C often gives people fits, and I want to take my time on part C. This says find g of x plus 2. Now, what that means is that you have to plug in the whole thing. Okay? So, let's see how that works. Well, the first thing I would do is write down the function. The function is g of x equals negative x squared plus 4x plus 1. So that means everywhere there's an x, I need to put in an x plus 2 as a quantity. And I'll go slow here so you see how that works. So this will be equal to the negative, or we could think of it as negative 1 times whatever my mess is squared. Well, my mess in this case is x plus 2. So instead of plugging in a number, I'm plugging in an x plus 2. Plus 4 times that quantity again. 4 times x plus 2, and then I still have the plus 1 on the end. So because I'm plugging in something with an x in it, I'm not going to get a number answer. I'm going to get an algebra expression with x's in it. So now we got to do some correct algebra steps. Right here, I need to either use the square of a binomial shortcut or FOIL. Okay, I'm going to use the shortcut, which is going to make it x squared plus 4x plus 4. But remember, it gets multiplied by negative 1. So this thing's going to be multiplied by negative 1. The next part's pretty easy. It's just distributive property. Plus 4x plus 8, and then plus 1 on the end. So what it boils down to is just some algebra simplification. I think I might be able to finish that down here at the bottom of this page. When I distribute this negative 1 through, I'm going to have negative x squared minus 4x minus 4, and then I still have plus 4x, and then I'll combine the 8 and 1 and make it plus 9. And you can see there's some things that go away. Those go away. And I'm just left with negative x squared plus 5. And that would be your answer to that problem. That is g of x plus 2. Okay? So be aware of all three situations and their differences. That's where your notes can help you tonight. Okay? Now, what about this type of function? And I don't know if you have seen this type of function in your Algebra 2 days, but this is called a piecewise function. And I will explain it after we get it written down. It's called a piecewise function because it's defined in two pieces. Now let's kind of talk our way through how it's defined. It says that this function is x squared plus 1 when x is less than 0, which I've kind of taught you to say when x is negative. Okay, so when x is negative, you use x squared plus 1. When x is positive or equal to 0, I use this function. Okay, so it's defined in two pieces, and we're actually going to learn how to graph these and everything. But for right now, you just need to know how to plug in values. So what if they said, find f of negative 2? If I wanted to find f of negative 2, would I use the top function or the bottom function? I would use the top function. So I'm going to use x squared plus 1, and I'm going to plug my negative 2 into that. Negative 2 squared plus 1, that will be 5. Okay? And so if I had f of 7, then I'd use the bottom function, right? Because I use this function when x is positive. So I'm going to use x minus 1, 7 minus 1 is 6. Okay? So that's how we work with a piecewise function. And there's all different kinds of functions you'll see. There's no way I can just cover them all or we'd be here forever. You'll see easy functions and harder functions. Just be careful with your algebra steps. Now the next thing we need to talk about is finding domain. Remember what I said on our last day of notes. I said that domain are the x values that work. Okay? And for most functions, it's nearly everything. But what about this function? F of x equals 1 over x plus 5. I'm going to give you two situations here, situation A and situation B. Situation B, we'll look at the square root of x minus 7. Okay, let's look at situation A first. Remember, domain talks about the x values that work in the function. Look at this function. I've got this expression in the denominator. Do you see an x value that would give me 0 in the denominator? Isn't it negative 5? If I were to do f of negative 5, I would get 1 over negative 5 plus 5, which is 1 over 0. Isn't that a problem in the math world? That's undefined. If you were to put that into your calculator, you would get error. This is a problem. Okay? So, but isn't that the only number that would give me a 0 in the denominator? So my domain for question A is all of the x's, all of the x values except negative 5. Now how do we write that? Let me show you. There's two ways we can write it. I can say all real numbers. You put that double line on the capital R, and that stands for all real numbers, such that x does not equal negative 5. That's one way that you could write your answer. All of the x values, okay, such that it doesn't equal negative 5. Okay, that's one way you could write it. Okay. The other way you could write it is with interval notation. And you need to know both. The other way that you could write it is we could say it's all the numbers from negative infinity up to -5, and we put a round parenthesis so that we don't include it. Everything from -infinity to -5, and we put this U for union. Union is kind of like and. All the numbers from -5 to +infinity. That's the other way we could write the answer. That's called interval notation. Notice, remember, these round parentheses mean that we do not include the -5. If you need to include it, you put a square bracket, which we've covered that. Now let's look at question B. If I have a square root function, can I take the square root of a negative? I mean, I can get an imaginary number, right, but I'm not going to get a real number. Okay, those aren't going to show up on the graph or anything. So, as I look at this x right here, what's the turning point? When do I start getting negative numbers? When x is what? Very good. When x is less than 7, right? Because, let's just pick one. If I do f of 5, then I get the square root of 5 minus 7, which is the square root of negative 2, which is a problem. Okay? So, if I'm talking about domain, remember, domain are the x values that do work. So my answer here, you just told me anything less than 7 is a problem. So that means the ones bigger than 7 are good, right? So the domain is all of the real numbers such that x is greater than, and it can be equal to 0, so I'm going to say greater than or equal to 7. That's one way that you could write it. So long as the x is bigger than 7 or equal to 7, we're good. The other way that I could write it with interval notation, okay, I'm going to show you both. With interval notation, I can't start at -infinity because anything less than 7 doesn't work. The very first number that works is 7. So I start at 7 and I go all the way up to +infinity. And notice I put a square bracket around the 7 because this time we include the 7. Okay, and that's the idea of domain, okay, in talking about a function. All right? So there's basically two situations to look for. All right? There is the rational function. Okay, this is called, remember we talked about these. This is a rational function. And then there's the square root. Okay? So, two situations to look for. Two situations to look for with domain are, number one, rational functions, like f of x equals 1 over x plus 5. Anything that has that x in the denominator, we're going to be concerned that there's going to be something that doesn't work. Rational functions and square root functions. Okay? Because both of them can give me problems, like the square root of x minus 7. All right? So, now let me ask you a question. If you're asked to find domain, some people get, confused. Let's say you're asked to find domain, and I'll just throw up this one. F of x equals 7x plus 12. Is that a rational function? Remember, rational is another word for a fraction function. It's a function where you've got an x in the denominator, maybe. Is this a rational function? No. Is it a square root function? No. Are there any x values that could give me something undefined? I don't think there is. Isn't this just a linear that we just got done working with? Isn't this just a line that goes forever? Okay? The domain of this function is easy. The domain, we could either say it as it's all reals. Just put the capital R with the double bar. We could say it's all reals, or we could say it's all the numbers from negative infinity clear up to positive infinity. Everything works in that function. Everything works in that function. Okay? How about this one? G of x equals 12 over x squared minus 3x. Is this one a rational function? It is. So remember what we're worried about with the rational function. We are worried about when is this thing equal to 0. So guess what? We have to set up a very simple equation to find that out. We're going to set the denominator equal to 0 and solve it. So we know how to do this. That's a quadratic. It's not a three-term quadratic, so I'm just going to factor x out of both, take an x out of both, and now I can split it up into x equals 0 and x minus 3 equals 0, which when I solve that, I get x equals 3. So what are those two numbers? Those are the two numbers that don't work. Okay? These two numbers, if I put them into this function, will give me a 0 in the denominator, which means they're both bad. Bad numbers. So what is my domain? My domain, writing it the first way, is all reals such that x does not equal 0 or 3. Because those are the two numbers that don't work. So the domain is everything else. Okay? Now if I were to write it in interval notation, I would start at negative infinity. The first bad value I come to is 0. So I'd put a round parenthesis around 0. Then I would say u, which stands for and. Then I go from 0 to 3. All of those values are okay. Union. Then I go from 3 to positive infinity. You kind of have to think, when you're writing it in interval notation, you have to think of a number line. Okay? Think of a number line for a second. If this is negative infinity, the two numbers that don't work are 0 and 3. Both of those numbers we need to leave out. Okay, so interval notation covers all the rest. Here's negative infinity up to 0, 0 to 3, and then 3 to infinity. Okay, and that's kind of how interval notation works. How about this function? Let's see, that was number 2, this is number 3. How about if I have h of x equals the square root of 4 minus x squared? Now remember, we cannot take the square root of a negative. Okay? So any time that this little expression right here is bigger than 4, don't I have a problem? Right? So what I want, the best way to do this problem is to set what's under the radical equal to 0. Just do that real quick. It's a very simple one to solve. Add x squared, 4 equals x squared. So x equals plus or minus 2. Now why did I go through all of that? Well, because if I put, what that tells me is that if I put in anything bigger than 2, it gives me the square root of a negative. All right, think of it. If I put in 3 here, 4 minus 3 squared is going to be negative. What if I put in negative 3? It's the same thing. It's the square root of a negative. So, the only numbers that work, if we think of a number line, the only numbers that work are the ones between -2 and 2. These numbers right in here are the only ones that work. Nothing else works. Okay? So what's the domain? The domain, I'm going to write this one in interval notation. It's everything from -2 up to 2. Boom. And it's okay for it to be equal to 2, because we can have the square root of 0. If I were to write it the other way, I would say all reals such that x is sandwiched in between 2 and -2, if I were to write it the other way. Those are the only x values that work. Now, one last thing that I want to talk about is, what if they tell you to find the values where f of x equals g of x, and they give you two functions. They give you a function f, whatever it is, and they give you a function g, whatever it is. What do they want you to do if they want you to find the values where set them equal to each other? Okay? Whatever this one is and whatever this one is, you're going to set them equal to each other and solve using the algebra steps that we've worked on this year. Okay? And I'm going to stop there for today.